So equations of lines in the coordinate plane. You guys are pros at this stuff, right? You know your slope formula for finding the slope? Okay. Slope is rise over run. You know what this little symbol is? Little triangle? What that's called? Triangle? It's change. Good. Change in y. You see change in y over change in x. Good. So how do we find the slopes between these 2 points? Super easy to do. We would call this maybe our x1, y1, and this our x2, y2, and then we just plug in, right? So we've got m, or slope, equals 2 minus 6 over 5 minus 0. We carefully do our arithmetic, and we get negative 4 over 5 as our slope, and that's it. So you're going to be asked to calculate the slopes of some lines. And then in geometry, we use that slope information to be able to tell if lines are parallel or perpendicular, which is the focus of this year. How do you know the lines are parallel? Same slope, and if they're perpendicular, opposite or reciprocal. If they don't fall into one of those categories, it's yeah. Yeah, they're just intersecting lines or whatever. All right. Or will eventually intersect. So we talked about 2 different ways that you might have learned last year to write the equation of a line. I'm going to do one of each here. The first one, seems like a lot of you actually learned the y equals mx plus b method here. So the y equals mx plus b method of writing the equation of a line. And then the other one, I'm going to ignore the instructions up there, is the y minus y1 equals m x minus x1. Point slope form is what we prefer in higher level math, actually. So here we have a point at 2, 3. So we go 2 and 3. Do you guys have graphs in here? So put a point at 2, 3. I'm going to show you a picture of it, what we're doing. So place a point at 2 to the right, 3 up, and then it needs to have a slope of 5. Now, if I, from this point, go up 5 and over 1, I'll go off the graph. What could I do that would be equivalent to going up 5 and right 1? Down, so 1, 2, 3, 4, 5, and left 1. Yeah. And so, and then I could go down 1, 2, 3, 4, 5, go right off the graph. But I have a line that looks something like this. It's drawn in. And it's crossing somewhere down there. The line's not real straight. That gives you an idea of what the line looks like. So the way to use y equals mx plus b method to find the slope of the line is to plug in everything that I know, solve for b, and then rewrite it, placing b back in the equation. So it looks like this. Do I know a y here? Yes. What is the y in this stuff? 3. It goes through a y coordinate of 3. Do I know m in this problem? 5. Do I know x?
Yes.
2. So I know everything but b. That's a b, not a 6. Can I solve for b?
Yeah.
Okay, go ahead and do that. What do you get for b? -7. Does that jive with my picture? Sort of, huh? My line's not very straight, but it makes sense, right? If I had drawn it a little more accurately, it would eventually have crossed at -7. So the equation of my line, this one, is, I'll write it in blue, y equals, so we would go back, put y in. What's the m, the specific value of m here? 5. Place x back in the equation, and then now I know what b is. It's -7. So there it is in slope-intercept form. Okay, the other way to do this, let's go ahead and graph this thing. We've got a point at -2, 6, so there's -2, 6. A slope of -5/2, so that means I go down 1, 2, 3, 4, 5, and right 2. So I'm a little more accurate on this one. I know what my y-intercept should be. It should be 1. There's the graph of my line going through -2, 6 with a slope of -5/2. Let's plug in everything we do know here. Okay, we're going to call this specifically x1, y1. Okay, specifically that's x1, y1. And we're going to leave the y and the x that don't have the little subscripts with them alone. So I've got y minus, what here? 6 equals, m is negative 5 over 2, x minus negative 2. And so if I were to rewrite this, it would be y minus 6 equals negative 5 over 2, x plus 2. And you could leave it like that. That's point slope form of the line. What you may see as you move into an algebra 2, they might rewrite it by placing the 6 over on the other side, adding the 6 over. Or they might rewrite it in slope-intercept form. And that would require you to distribute here and then add the 6 over. But this one has a slope of negative 5 halves, and it goes through the point negative 2, 6. Notice it's the opposite of the sign that you see here, right? So there it is in point slope form. I don't care, you use either one. So slope-intercept, point slope, you just need to be able to write the equation of the line through a point with a given slope. Okay, using one of those two methods. Is that all right? Okay. And then you should also be able to graph it. And ask you to graph some of these. All right, another question here. It says, what are the equations of the horizontal and vertical lines through 2, 4? Well, let's draw a picture here. We've got 1, 2 over, 1, 2, 3, 4 up. There's the point 2, 4. Horizontal and vertical lines go like this. Horizontal lines are y equals lines. Vertical lines are x equals lines. A horizontal line going through 2, 4 would look like this. The equation of the horizontal line through 2, 4 would be y equals whatever the y coordinate is here that it just stays at, or the y coordinate of the place where it crosses the y-axis. What's the y coordinate here? 4. So it's y equals 4. A vertical line would look like this. It just stays at x equals 2. And so horizontal lines are y equals whatever the y value is that it goes through. And vertical lines are x equals lines. And it corresponds to whatever the x value is that it goes through. Okay, so we have horizontal. Do you guys remember horizontal and vertical line? Do you remember what the slope is of the horizontal line? 0. And then the vertical line, we would say it's the slope of it. It's a special case. It does, yeah, it's undefined. It's undefined. It's not a function. So vertical lines are undefined slope, horizontal has slope of 0. And then we saw one with a positive slope here, right? Positive sloping, negative sloping line. So you should be able to picture kind of the 4 different types of slopes: positive, negative slope, 0 slope, undefined slope. You see each of those cases up there? I don't know if you can see that. It's the red one here, the red, red, red. So this one would be what kind of slope, if we just think in general? Positive slope, yeah. Oops. No, he's not going to do it. Positive slope. There we go. And then this one right here, it's the red line right here. Or it might be this red line. Doesn't matter. It's, they say no slope. So we're going to call that 0 slope, I think he said. Slope of 0. It would be like the floor here. You know, what's the slope of this floor? Slope of this floor is 0, or it has no slope. That's what we're saying, no slope. So it's 0 slope. It's level. And then this red line over here, we would say has undefined slope. And then we've got one with negative slope here. Like that. So you should be able to picture the 4 different types of slopes. You should be able to write the equation of a line through a point with a given slope. You should be able to calculate the slope. That was the first example. And then tell me if lines are parallel or perpendicular. That's actually going to be the next lesson that we'll do. So I don't think this homework will be real difficult. It shouldn't be too bad. Okay. So let me